Hello, good morning everyone. So today we are here to discuss NEET 2026 physics paper. I hope you have done good and you are waiting for your result. So let's see the paper. If you talk about the toughness level, so it is easier than 20. I'll say easier than 2025 paper, and it is little bit on the tougher side if you compare it with 2024. Yes, some calculation part was there, but still the paper was easy. If you have planned well, you could have scored very good in physics, right? So let's see, let's discuss the question one by one. First one is a 100 turn closely wound circular coil of radius 5 centimeters. So whatever the information is given, how you should proceed. So whatever the information is given, just try to convert it, write it down, right? Like 100 turns, okay, so I'll write down all the information. N equal to 100, n equal to 100. Then what else is given? A radius r is equal to 5 centimeter, so 5 into 10 to the power minus 2 meter, right? And then magnetic field B is given as 3.14 into 10 to the power minus 3 Tesla at its center. The current flowing through the coil and the magnitude of magnetic moment. So if there is a coil, it is having 100 number of turns. This coil is having 100 number of turns. Fine. You know the magnetic field. What is the magnetic field at the center? If it carries a current I, so what is the magnetic field at the center? So magnetic field at the center is given by mu naught Ni divided by 2R. Right or not? The magnetic field at the center will be given by mu naught Ni by 2R. Fine. So let's put the expression here. B value already given. We have to find out the value of I. So what you will get? 2BR divided by mu naught N. So 2 into 3.14, I can write it as pi into 10 to the power minus 3. R is 5 into 10 to the power minus 2 divided by mu naught is 4 pi into 10 to the power minus 7 and N is 100, right? So many terms will be cancelled out. If you can see, you can solve it very easily. How much you are going to get? So 4, 5 to 10, 10 by 4 into this is 100, 10 to the power minus 3, minus 2, minus 5. Here it is minus 7. So it is 10 to the power 2, right? So here it is 10 to the power 2 divided by 10 to the power 2. So you are going to get it as 10 by 4. So 2, 5. So it is 2.5 ampere. Very easy. So 2.5 ampere. So two options you can easily neglect. 2 ampere, 2 ampere. So answer is 2.5 ampere. So out of this 1 and 2, one option is correct. Now we have to find out the magnetic moment. Magnetic moment is given by NIA. Magnetic moment is given by NIA. So what is the value of N here? 100. Current is 2.5. Area is pi r square. Pi into r square, that is 25 into 10 to the power minus 4. Yes, some calculation part is there. So let's just see how much we are getting. 10 to the power minus 4, if I take it here, so it is 2.5 into 25 into pi into 10 to the power minus 2. For an example, suppose you want to approximate, how you are going to approximate? Just see. Can we get, do you need to multiply this? No, you don't need to multiply this. Why I am saying this? Because 25 into 2.5, how much it is going to come? 25 into 25 is 625. So it is going to come 62.5, right? Multiplied by 3. Approximately 190 you are going to get, 196 something. But if you multiply it with 10 to the power minus 2, so definitely the value is going to be less than 20, right? So which one should be the correct option? Option number 1 is the correct one. We don't need to multiply here, but if you want, let's check it how much we are getting the value here. I'll just calculate the value, so I'll let you know. So just let me calculate. 2.5 into 25 into 3.14, So it is coming out to be 196.25, 196.25 into 10 to the power minus 2. So roughly you are going to get it as 2 ampere meter square, right? So which one is the correct option? But you don't have to multiply in the examination. Make sure that you should know how to approximate. Fine. Let's move to the next question quickly. Now match list 1 with list 2. E is equal to h nu, diffraction and interference, lambda is equal to h by p. These are the, you know that these are the de Broglie wavelength. E is equal to h nu. What is it? Energy of a photon. So E is option number 4. So definitely this option is gone. That is not a correct option. Next one is diffraction and interference. From where we are getting this diffraction and interference pattern? It is, explained by considering light as a wave. So it is a wave nature of light. So B is option 3. So B is option 3. So only first one. Fourth one is also there. So this one is gone. Next one is lambda is equal to h by p. What it is? It is your de Broglie wavelength. So C is 1. So option number 1 is the correct one, right? So this option is neglected. Done. Very easy question. You could have done in fraction of, I'll say fraction of seconds. Now next question. Question number 3. The current I in the circuit shown below is, you have to find out the current I in the circuit. Means how much current is coming out from the battery. See, if current is flowing here, is it possible that current will go through this path? No, it is not possible. Why? Because this diode is reverse bias. In case of reverse bias, diode is considered to be providing infinite resistance if it is not crossing that breakdown voltage. So definitely there is no current flowing through this branch. This branch, yes, current will flow. This branch, will there be any current? No. Why? Because it is reverse bias. So only two resistances are there. One is 4 ohm, 2 ohm. So you can just replace it with a simple 4 ohm and simple 2 ohm resistance. This one is 4 ohm and this one is 2 ohm. So what is your R equivalent? You know that it is 4 into 2 divided by 4 plus 2, which is 6. 2, 3, 2 cancel. How much you are getting? 4 by 3. This is your 10 volt. So I is equal to V by R, that is 4 into 3. 2, 5. How much we are getting? 15 by 2 ampere. So which one is your correct answer? Option number 2 is your correct answer. Fine. So let's move to the next question. The speed of light in vacuum is taken as unity. You are considering speed of light as unity. So C is equal to 1 unit. For an example, light takes 6 minutes 40 seconds. How much time it is taking? 6 minutes 40 seconds, right? So what is it? 6 minutes is 360 plus 40 seconds. How much it is? 400 seconds, correct? Now if it is taking 400 seconds, so what is the distance? You know that distance is equal to speed into time. Speed is how much? 1 into 400. So that is 400 unit. Here also it will become 400 unit. So which one is correct? Option number 3. Clear? Very easy question. You could have done it in very less time. Next one. The following plot shows variation of velocity v with time t of a ball thrown vertically upward. You are throwing a ball upward, so definitely it will come back and falling back. Which of the following plot is correct? Which of the following plot is correct? You have to draw the velocity time graph. Now tell me one thing, what will remain constant here? Acceleration. Does acceleration changing its direction? Think in that direction. Is acceleration changing its direction? Because we have to draw velocity time graph, and you know that the slope of velocity, whenever the graph related question is there, first think about the slope, whether any information you are getting with the slope, and then think about the area. If you are getting any information through the area, and then you should use your common sense. Here first we will see the slope. What does the slope of VT graph will give? Slope of VT graph is going to give you acceleration, right? And in this case, is acceleration changing? Tell me, is there any change in the acceleration? No, neither in the direction nor in the magnitude, correct? So acceleration is constant. If acceleration is constant, Means what? Means what? Can we, is it the correct option? No. Acceleration is constant means slope is constant. So slope here, it is changing, right? So it cannot be the option. Here also slope is changing. It cannot be the option. It cannot be the option. Yes, this can be the option. This can be the option. Here also slope is changing. So this cannot be the option. Right? Now think, you are throwing an object up, right? So what will happen? What is going to happen? You are throwing it with certain velocities. So upward when we are taking positive, right? And downward we are taking negative. So here the slope is negative. First one, slope is negative, right or not? So slope is negative means your acceleration. Slope is negative means obtuse. Slope is negative means it is obtuse. So here acceleration, if you want to write down the equation, you can write it down. V is equal to u minus gt. V is equal to u minus gt. So definitely minus g is the slope. Minus g is the slope. So slope is negative means it should make an obtuse angle, right? So option C is the correct one, right or not? Then let's move to the next part. So which one is the correct option here? C, option 1. Next, in a vernier caliper, see, you know, when you are attempting a physics paper, you should select 30 questions which were very easy, and trust me, in every examination paper, whether it is 2025, whether it is 2024, any year paper, you just take it out, you will find 30 questions which is relatively very easy. You can do it in a very less time, right? So you have to select those 30 questions first, and then go for the 35, then go for 40, then go for 45. But that 30 question you should do, which is very easy to do, very easy in calculation part. So selection of those question is very, very important. Now in a vernier caliper, let's move to this question. 20 VSD coincide with 16 MSD. Each division of length is 1 mm. You know that list count of a vernier caliper will be given by MSD, main scale division, minus VSD, right? MSD minus VSD. What is MSD here? 1 mm. 1 mm. 1 mm. VSD is how much? Okay, let's to find out the value of VSD, can I directly write 20 VSD is equal to 16 MSD? Yes or no? So can I write 16 mm? So 20 VSD is equal to 16 mm. So 1 VSD, how much you are getting? 16 by 20 mm, right? So 1 mm minus 16 by 20 mm. How much you are getting? 20 minus 16 is 4 by 20 mm. So it is 1 by 5 mm. So you are going to get it as 0.2 mm. So 0.2 mm, 0.02 centimeter. So basically it is 0.02 centimeter. One more thing, you should be here you are getting 0.2 mm by mistake, since you are having a lot of pressure in the examination hall. So you should be very careful which unit they have given. You should not mark this 0.2 centimeter, because these are the common mistakes students are doing. Even after solving the paper, they are marking the OMR wrong. You should be very careful which unit they have given, whether it is in centimeter, whether it is in millimeter. Next, an AC circuit contains a resistance of 1 kilo ohm, a capacitor of 0.10 microfarad, and an inductor of 1 millihenry connected in series. The resonance frequency of the circuit is approximately. What is the resonance frequency of the circuit? Do you know the formula of the resonance circuit? At the resonance, you know that XL equal to XC. The current should be maximum. At resonance, the current is maximum. Basically, power is maximum, right? So current is maximum. It is only possible when XL equal to XC. Okay, XL is equal to L omega. I am writing. I am just trying to make you aware about this. What is XC? 1 by C omega. From here, you will get omega square is equal to 1 by LC. Correct or not? Yes or no? So what is your omega? Omega is your 2 pi by T is equal to root over 1 by LC. So what is your time period frequency they are asking? So time period T is equal to 2 pi root over Mhm. LC. So what is your frequency? 1 by 2 pi root over 1 by LC. Correct? Is it fine? 2 pi root over 1 by LC. Is it okay? Right? So now your work is done. Nothing is there in this. Nothing is left. So what should we do now? What should we do now? We should put the values, only values, nothing else. So just put the values 1 by 2 pi root over 1 by, what is the value of L? L value is 1 millihenry. So that is 10 to the power minus 3, and capacitance value is, how much it is? 0.1. So 0.1 into 10 to the power minus 6. Correct. Now rest is your calculation only. So let's check the calculation, how much we are getting. 10 to the power minus 6, 10 to the power minus 3, that is 10 to the power minus 9, and 1 10 to the power minus 10. So here it is 10 to the power 10, right? So 10 to the power 10, so 1 by 2 pi into 10 to the power 5, correct? So 2 pi is, we can write it as 1 by, approximately let's write it to be 6 approximately I am writing, so that we can get the approximate value, but they are very close to each other. So 3.14 only let's take, not to take risk. So 1 by 3.14 multiplied by 2, so 6.28 into 10 to the power 5, right? So 10 divided by 6.28, 100 divided by 6.28, how much we will get? I am doing the calculation. 100 divided by 6.28, you are getting it as 15.9. So it is 15.9 kilohertz. Is it clear? So only here calculation part is there, rest the question is very straightforward. You don't have to put any brain in it. So 15.9 kilohertz. So which one is the correct option? Option number 3. Next. Okay, in this case, I hope you are aware about this type of question, where what it is given a long straight solid wire of circular cross section of radius A, long straight wire of solid wire of circular cross section of radius A carrying steady current I. The current I is uniformly distributed across its cross section. The plot which correctly represent the variation of magnetic field B with distance r from the axis of the conductor in the region. Region. Sorry. So in this case, you know that if I consider any loop, Amperian loop, so line integral of magnetic field B dot dl is equal to mu naught I. What is I? I is the current which is threading through it. So in this case, we will consider one small section having radius small r, and we will try to find out the current in it. So current is uniformly distributed. So I is equal to, can I write? See, I by I dash is equal to area. Area is how much area? Let us assume the current density is sigma. So sigma into area is pi a square divided by sigma into pi small r square. Can I write like this? Yes or no? So here what we will get? So sigma cancel, pi cancel. So I dash is equal to I into r square by, I am doing the correct total derivation of it. So from now again we will use the ampere. Suppose you don't know the expression, then you can use this expression to get it. So line integral of inside I am talking about. So B dot dl. So here what we need, magnetic field is constant. So B we can take it out. DL, what is it? 2 pi into r, that is equal to mu naught into, what is the current? I small r square divided by a square. So this r and 1 r will cancel out. So what you will get? B is proportional to r. What you are getting? This is the case when r is less than a. So we are getting B is proportional. Which one is straight line? B is proportional inside. Is it a straight? No. Straightforward? No. Is it 0? No. Is it? No. This is the correct option. You don't have to derive for the external one, right? So very easy, and you must have got the direct formula also related to that. Can I change? I hope you have understood this question. Let's move to the next part. This is also I think this is also a very straightforward question. A uniform metallic wire having resistance 4 ohm. A uniform metallic wire having resistance 4 ohm. Okay, wire is having a resistance 4 ohm, is bent to form a square loop ABCD. ABCD, fine. A resistance of 2 ohm is connected between points B and D, and a battery of 2 volt is connected across point A and C. Now battery of 2 volt is connected across the point A and C. Now the value of current I is, what is the value of the current I? You have to find out the value of the current, this current I. Fine. 1 ohm, let's mm, draw it 4 ohm. So what is the resistance of each wire, each section of the wire? 1 ohm. Here 1 ohm, this one is also 1 ohm, this one is also 1 ohm, and this one is also 1 ohm, right? 1 ohm, 1 ohm, 1 ohm, 1 ohm. Now don't you think these wires and this wire, if you see it, then you can realize that this one is actually forming a balanced Wheatstone bridge. So there will be no current flowing across this 2 ohm resistor, right? Now this, it becomes very easy, you can just redraw it. So how it will be, this is your, suppose A to B, 1 ohm resistor is there, then B to C another 1 ohm resistor is there, then again A to D 1 ohm resistor is there, and then D to C 1 ohm resistor is there, and it is connected with a battery of 2 volt, connected with a battery of 2 volts. So this is 1 ohm, 1 ohm, 1 ohm, 1 ohm. So R equivalent will 1 plus 1 2, 1 plus 1 2, and 2 and 2 are in parallel combination, so it will become 1. So it will reduce to 1 ohm, and this one is 2 volts. So what is the current? I is equal to 2 ampere. I is equal to 2 ampere. I hope they are asking I, right? Current I is 2 ampere. Is it fine? Done? Okay, let's move to the next. An unknown nucleus has a nuclear density of 2.29 into 10 to the power 17 kg per meter cube and mass of 19.926 and 10 to the power minus 27 kg. Its mass number A is approximately, see, you can when you are reading this question is actually easy only, but the thing is here calculation is more. So in the examination, I'll suggest you to do this question after, at last. Why? Because calculation part is more, so it is a little bit time consuming. Fine, I'm not saying it is tough, but it is a time consuming. Now here, mass is given, and then nuclear density is given, so rho is given. I'm writing all the information. 2.29 into 10 to the power 17, then mass m is 19 I'm not writing the unit, 10 to the power minus 27. Okay, fine. Then mass number A. Okay, A is your mass number. A is equal to mass number, right? Now, okay, we know that R equal to radius. If you remember, R is equal to R naught A to the power 1 by 3. R equal to R naught A to the power 1 by 3. So what I'm going to do, I'm going to multiply and volume. So let's multiply it with 4 by 3 pi R cube. So it will become how much? So 4 by 3 pi R naught cube into area A, right or not? This is the volume. This is what? This is the volume. So volume is equal to 4 by 3 pi R naught cube into area A, and volume, you know that it is mass by density, is equal to 4 by 3 pi R naught cube into mass number A, right or not? So what is the value of A? The value of A will come out to be 3m divided by 4 rho pi R naught cube. Are we getting this? After that, just substitute all the values. So 3 into mass number is 19.926 0.926 into 10 power minus 27, right, divided by divided by okay, so divided by this value 4 into, so what is it, 4 into, what is the value of density here? Density is 2.29, 2.29 into 10 to the power 17. Then next is pi, pi, and then r naught cube. So r naught value is 1.2 into 10 to the power minus 15. So this is what we are getting, correct? 4 pi value they have already given, so I'm doing it here. So a is equal to 3 into 19 point, let's write it down, at last we will solve it. 19.926 into 10 to the power 17 minus 15, that is 2, minus 27 plus 2, minus 29, correct? Did I miss anything? Oh, it is cube, sorry, it is cube, correct. So cube is into minus 27, 15 minus 15 cube is 45, 17 minus 45, so 45 minus 17, 45 minus 15 is 30, 30 minus 2 is 22, uh, 28, 28, so it is 10, minus 28, minus 28, it will go to, it will become plus, so 10 to the power 1 divided by 4 pi into 2.29, 2.29 into 1.2 into 1.2 into 1.2, right? So let's solve it, how much we will get. So let's do the calculation part here. So 4 pi value is already given, 3 into 19.926 into 10 divided by 4 pi is 12.56, anyway we can calculate also, 12.56 into 2.29 into 1.2 into 1.2 into 1.2, right? So let's calculate it. So I'm doing the calculation here. So here calculation part is a little bit more, so that's what make it lengthy. 19.926 into 10 divided by 12.56 into 2.29 to 1.2 into 1.2 into 1.2. So it is coming out to be 12. Did I miss anything? So it is approximately coming out to be 12. Is it so? So let me check the option what they have given here. Yes, correct. This is correct option. So option number 12 is option number 1 is the correct one, right? Fine. Can we move to next? Let's see. A rectangular wire loop of side 8 centimeter and 3 centimeter with a small cut is moving out of a region of uniform magnetic field. Side 8 centimeter and 3 centimeter with a small cut, a rectangular wire, let us assume like this, is moving out of a region of uniform magnetic field of magnitude 0.3 Tesla, directed normal. It is directing normal to this plane, and it is moving out. It is moving out with a uniform velocity v, right? 2 centimeter per second, where v is 2 centimeter per second. It is moving out with a uniform velocity. It is 8 centimeter into 3 centimeter, a rectangular wire loop of side 8 centimeter into 3 centimeter. So they are saying uh, in a direction normal to the shorter side of the loop, in a direction normal to the shorter side of the loop. So this is the shorter side, normal to the shorter side. So let us this diagram I have made it, so I have to made this one a longer one, right? Correct. So this is what we are getting. So you know that EMF, motional EMF, this is the question of a motional EMF. So E will be equal to, for a motional EMF, you know that E will be equal to BLV, right? And what is the length here? It is let me check, in a direction normal to the shorter side of the loop, in a direction normal to the shorter side of the loop. Yes, correct. So what is it? So E is equal to BLV. What is the value of L? L is 0.3 centimeters. So magnetic field is 0.3 Tesla. L is 3 into 10 power minus 2 and velocity is 2 into 10 power minus 2. So how much it will become? 339 to 18. So 1.8 into 10 to the power minus 4 volt. So 1.8 into 10 to the power minus 4 volt. Correct. So option number 1 is the correct option. I hope it is clear. Next, a galvanometer of resistance 100 ohm gives full scale deflection for a current of 1 milliampere. It is converted into an ammeter of range 0 to 10 ampere. The shunt required is, okay, so there is a galvanometer, there is a galvanometer and one shunt, oh sorry, ammeter we are converting, right? Fine. So yes, fine, we are converting it to ammeter 0 to 10 ampere. So let us assume what is the shunt we have to apply. So this is your current I for an example. So it will get divided Ig and this one is will become I minus Ig. This shunt is your S. Can we use the Kirchhoff law here? Can we use the Kirchhoff law here? So let us assume this is plus, this is minus, this is plus, this is minus. Take this loop A, B, C, D. Very easy way I am telling you. Mark this plus and minus. Current always flows from higher potential to lower potential, higher potential, lower potential. And take any loop. Suppose I am taking loop ABCD. Loop ABCD. We could have done it directly also, but I am giving you this way. Loop ABCD. So what is the current? Ig into G, plus to minus. Plus to minus. So it is minus Ig into capital G. Then again here minus to plus, it should be plus, increasing. Minus to plus, you can remember it like minus to plus, it is increasing, so it is plus. So plus I minus Ig into shunt resistance S, and that is equal to 0. Is it fine? Can I say this I minus Ig is approximately 0 only because shunt value is very less, right or not? This I minus Ig, maximum current will flow through this one only. So I minus Ig is approximately, this is approximately equal to I only, right? So from here I into S, that is equal to Ig into capital G. So what is your shunt? Ig into capital G divided by I. What is the I? 10 ampere. Ig is how much? 1 milliampere. So 10 to the power minus 3 into capital G is 100 divided by current I is 10 ampere. How much it is? 10 to the power minus 2 ohm. 10 to the power minus 2 ohm. So which one is the correct? 0.01 ohm. 0.01. Let me check the answer. Okay, it is correct. Yes, 0.01 ohm is correct option. Fine. Can you move to next? Yeah. In Young's double slit experiment using monochromatic light of wavelength lambda, the intensity of light at a point on the screen where the path difference is lambda is k unit. The intensity of light at a point where the path difference is lambda by 3. So just give me 1 minute. Okay, Young double slit experiment You are aware, right? One question definitely it is there from Young double slit experiment in every paper. So in Young double slit experiment using monochromatic light of wavelength lambda, the intensity of light at a point on the screen where the path difference is lambda is k unit. Where the path difference is lambda, you know that the fringes which is formed in Young's double slit experiment are having equal intensities, right? Whether you are talking about the dark fringe or you are talking about the bright fringe, they will have equal intensities, correct? Now in this case, when path difference is lambda, when your path difference is lambda, delta x equal to lambda, it will be constructive or destructive interference. Path difference is lambda means what? So another wave is traveling like this. So what type of interference it will form? Constructive interference. Constructive interference intensity will be maximum. So here in this case maximum intensity is k unit. So I max, can I say I max equal to k, right or not? Correct. Now I is equal to, you know that formula, I is equal to I naught cos square phi by 2. Is it fine? And how much it is? Or you can write it as 4 I naught. If this one is having intensity I naught, this one is having intensity I naught, then it will become 4 I naught. And here 4 I naught is equal to k. 4 I naught is equal to k. So here it is k cos square phi by 2. What is the path difference? Lambda by 3. So what is the relation with the path difference and phase difference? So delta x equal to, sorry, delta phi is equal to 2 pi by lambda into delta x. Put that value 2 pi by lambda. What is the value of delta x? Lambda by 3. So this lambda and lambda will cancel it out, 2 pi by 3. So it is cos square pi by 3. 2 will cancel it out. What is the value of cos pi by 3? Cos pi by 3, cos pi by 3, cos 60. Cos 60 value is, cos 60 value is 1 by 2. 1 by 2 square is 1 by 4. So how much it will become? K by 4, right? How much it will become? K by 4. This is also one of the easiest question, I'll say, where the calculation part is also less. It does not involve so many calculation like the previous question. Fine. Next. The magnitude and direction of the acceleration produced in a body of mass 5 kg when two mutually perpendicular forces 8 Newton and 6 Newton acts on it. There is a body, there is a force, let us assume 8 Newton is acting in this direction, and there is a force 6 Newton is acting in this direction. What is the direction? Definitely it will move in this direction, right? And this is having 5 kg, right? You have to find out the magnitude and direction of the acceleration. Direction is very easy. Direction is what? This angle, net force. The direction of acceleration will always along the direction of the net force. What is the direction of the net force? This is the direction of the net force. And if I write this is theta, so tan theta is equal to what we can get? 6 by 8. Tan theta is equal to 6 by 8 with 8 Newton. So it is 3 by 4 with 8 Newton. 3 by 4 with 8 Newton. Correct? So 3 by 4 with 8 Newton. Okay, fine. Or if you are talking about this angle phi, so tan phi is equal to 8 by 6. That is equal to 4 by 3. So both option is there. This is with which one? With 8 Newton, and this one is with which one? 6 Newton. Clear? Now acceleration you need to calculate. So what is the net force? So F net is equal to, since both are perpendicular, can I write 8 square plus 6 square? 64 plus 36 root over 100. So that is come out to be 10, and F net is equal to mass into acceleration m into a. So mass is 5 kg. So 5 into a, that is equal to 10. So 5 2. So a is equal to 2 meter per second square. So acceleration is coming out to be 2 meter per second square. So which one? Just check it. Which one is the correct one? So with 2 meter per second square and 3 by 4 with 6 Newton. That is wrong. 2 meter per second square, 4 by 3 with 8 Newton. That is also wrong. Correct. Now 2 meter per second square, 3 by 4 with 8 Newton. So yes, definitely this option number 3 is the correct one. This option is straightforward wrong because it cannot produce a acceleration of 20 meter per second square, because none of the forces is I will say for 20 meter per second square the net force required is 20 into 5, which is 100 Newton. This 8 Newton and 6 Newton force, maximum force it can exert is 40 Newton, right? So this option 4 you can just logically you can cancel it. Next, 5 capacitors of capacitance C1, C2, C3, C4 that is given as 10 microfarad, C5 is given as 2.5 microfarad, are connected as shown along with a battery of 50 volt. It is connected with a battery of 50 volt, C1, C2, C3, C4 and C5, where C1, C2, C3, C4 and are equal, right? And it is equal to 10 microfarad. Fine. This is also 10 microfarad. This one is also 10 microfarad. This one is also 10 microfarad. And C5 is given as 2.5 microfarad. 2.5 microfarad. Right. Write down the information. Once you are getting this, write down the information quickly. And you know that. Where is C4? One. I think here it is C4. Diagram is missing here. Anyway. So you have to find out the equivalent capacitor and the charge on each capacitor respectively. What is the, when it is connected in series, this one C1, C2, C3, C4 is connected in series. So in series, for series combination, what is your 1 by C equivalent? In this case it will become 1 by C equivalent is equal to 1 by C1 plus 1 by C2 plus 1 by C3 plus 1 by C4, right? So 1 by C equivalent is coming out to be 4 by C, and C is 10 microfarad. So C equivalent will be equal to 10 by 4 microfarad. Is it fine? You can do it directly also. I have given you the formula. Now after getting this, C equivalent of this one, and then again C5 is also there. So C equivalent dash, this is for the series. So C equivalent dash is 2.5 plus 10 by 4. 10 by 4 is how much? 2.5 plus 2.5. 10 by 4 is how much? If you want 5 by 2, 2.5. So 2.5 plus 2.5. So 5 microfarad. Correct? 5 microfarad. So which one is? So this option is cancelled. Right? This one is also 2.5 microfarad, and this its equivalent is also 2.5 microfarad. Don't you think here the charge Q is equal to, this is parallel combination, so voltage will remain same. So here, suppose here 50 volt is there, so in this cases voltage will be divided into 4 equal parts. 50 volt, 50 by 4, so each will receive 50 by 4 volt. Each one will have 50 by 4 volt, and C5 will have 50 volt. So what is the charge on this C5? So charge, so Q is equal to, first we will calculate 50 volt we are getting, so Q is equal to C into V. What is your C? So 2.5 into voltage is 50 microcoulomb, right or not? 25 into 5 is 125 microcoulomb. 125 microcoulomb. So 125 microcoulomb will be on C5. So 125 microcoulomb on C5. Is it clear? Now, fine. Now here 50 by 4 multiplied by 10. What is your Q? Q is equal to CV. So 50 by 4 into 10. Same answer you are going to get. Microcoulomb. Same answer you are going to get. 2, 2, 2, 5. Here again to 25, 125 microcoulomb. And in series combination, the charge remains same. So what is your equivalent? 5 microfarad and 125 microcoulomb on all capacitor. That's it. So option number 1 is correct. That is also easy. Next, in a meter bridge experiment, the position of the cell E and galvanometer G are interchanged, right? Okay, you are changing the position of this E and this G, galvanometer. You are changing the position of this E and galvanometer G are interchanged. We shall observe in the galvanometer. What we are going to, just tell me the answer, what we are going to observe here? What we are going to observe here? Hello. So we will see the deflection here in this case in a meter bridge experiment. If you are talking about, sorry, the mic was not working. The position of the cell E and G, you are interchanging it. So this is a balanced Wheatstone bridge condition. Even if you are changing the position of galvanometer and E, still it is a balanced. And when it is balanced, there is no deflection irrespective of the changing the position of the galvanometer. But other than that balance condition, other than that, there will be a deflection. So other than that, there is a deflection. So it will have a deflection in both sided. At the balance point, there will be no deflection. So that is correct. So interchanging the position of E and G, it is not going to affect anything. Now next, the power of a crane which lifts a mass of 1000 kg to a height of 20 meter in 10 seconds. What is the power of a crane? It is lifting a mass of 1000 kg to a height of 20 meter in 10 seconds. So what is the work done? What is the work done this crane is doing? So work done will be mgh, right? So power. So if I talk about the power, so work done by time. What we can write? mgh divided by t. How much mass it is? 10,000 kg. Let take the value of G as 9.8. Okay, they have taken 9.8, no issue. To a height of 20 meter in 10 second. So this 10, this one will cancel it out. How much you are getting? 19.6 into 10 to the power 3 watt. So which one is the correct one? Option number 4, 19.6 kilowatt. 19.6 kilowatt, right? Next, match list 1 with list 2. I hope this is an easy question. It's a direct formula based. Tell me which one is Young modulus. What is Young modulus? Young modulus, it is force by area divided by delta L by L, right? So Young modulus, why we are writing, so we can write it as F into L divided by A delta L. So which one is satisfying that? So Young modulus is this one, option number 2. So A2, only one option is satisfying it. Only one option is satisfying it. You don't have to check the other one. If you want, we can check. Compressibility is what? It is the reciprocal of what? Reciprocal of bulk modulus. Compressibility is your reciprocal of bulk modulus. So bulk modulus, you know that bulk modulus B is given by pressure divided by delta V by V with a minus sign, definitely. So what it will become? Minus P into V divided by delta V. So this is your bulk modulus. Reciprocal of that will be your compressibility. So bulk modulus, option number 4, although we don't need it. So B, option number C, option number 4. Yes, correct. C, option number 4. Compressibility, reverse of that. So C, option number 3 will be correct. B, option number 3 is correct. Yeah, A, option number 2 is correct. Last one is D, Poisson's ratio. So this one is your correct one. Is it fine? Okay, let's move to the next part. In a concave lens, a ray of light emanating from the object parallel to the principal axis of the lens after refraction. In a concave lens, we are talking about a concave lens. So this is our concave lens. Fine. A ray of light emanating from the object. It is emanating from an object parallel to the principal axis of the lens after refraction. What will happen when the ray of light, which is emanating and it is parallel to the principal axis, any ray of light which is parallel to the principal axis, it appears to diverge from the first principal focus, or next one is third one is passes through 2f, which is the radius of curvature of the lens, passes through the second principal focus. See, first one is whenever a ray of light is passing through the concave lens is called as diverging lens, right? So it will be like this. So it is appear to come out from the focus, or appears to diverge from the first principal focus, right? It is appearing to diverge from the first principal focus. So which one is the correct option? Option number 2 is the correct option, right? Clear? Next. Okay, this question. A thin wire of length L and linear mass density M. It is M. Okay, let us assume linear mass density is M, is bent into a circular ring. We are bending a wire in the form of a circular ring. So wire is having a length L. There is a wire. This wire is having length L and linear mass density is M. Is bent into a circular ring in XY plane. This is your XY plane. Okay. With a center C as shown in the figure, the moment of inertia of the ring about an axis y dash. What is its moment of inertia? First one, we need to calculate its radius. Can I say 2 pi r is equal to L? So what is the value of r? L by 2 pi. Okay, fine. What is the moment of inertia about this axis? Right? So what we can do? We can use I'll just brief you about how to use that. You know that moment of inertia about this axis is mr square. For a ring, it is mr square. Now we can use the perpendicular axis theorem. So this one will be I, this one will be I. So I plus I is equal to mr square. So what is the value of I? Mr square by 2. So moment of inertia about this axis is equal to mr square by 2. So now we can use the parallel axis theorem. I dash about this axis. So I dash will be equal to mr square by 2 plus mr square. Although you can remember this value directly. So 3 by 2 mr square. Right? What is the mass? Mass is the length. So 3 by 2 total mass is small m into L. R square is L square by 4 pi square. So how much you are getting? 3 by 8 ml cube divided by 4 pi square. Which one? 4 pi, sorry, 8 pi square. 3 ml cube divided by 8 pi square. Option number 1 is correct one. Option number 1 is correct. Option number 1 is correct. Let's see next one. Each side of a metallic cube of mass 5.580 kg is measured to be 90 centimeter. There is a metallic cube. There is a metallic cube. Now each side of a metallic cube of mass 5.580 kg is measured to be 9 centimeter. Okay, this mass is given as 5.58 kg is measured to be 9 is measured to be 9 centimeter. L is equal to 9.0 centimeter. Keeping the significant figure in view, the density of the material of the cube can be best expressed as, Okay, no issue. So can I write it as 9.0 into 10 power minus 2 meter? Fine. Next, we can multiply this one. So what we are going to get? Hmm, the density of the material. So rho is equal to mass by volume. So mass is 5.580 and volume will be equal to L cube, right? So 9.0 into 9.0 into 9.0 into 10 to the power minus 6. Correct or not? Meter cube. Now when you are multiplying two number, then the result should contain that number of significant figure which is least among them, right? So it is 5.580. So how much we will get? First we will multiply, at last we will do the calculation part. So in the beginning we won't consider it. So 99729 into 10 power minus 6. Let it be 10 power minus 6, go to that point. 5.580. Here we can write it as into 10 to the power 6, right? Divided by 729. Okay, so this one we can write it as 5580 divided by 729 into 10 to the power 3 minus 3. So here it is 3, right? So how much we are going to get? 729, 5580. So I'll just use the calculator for this one. Without calculator also you could have done it. So let me check. 5580 divided by 729, 7.654. So we are getting 7.654 into 10 power 3. So this is your significant figure. So in the answer, which how much minimum is, it is 9 centimeters. So you have to take only up to 2 significant figure. When you are dividing a number, you have to consider only 2 significant figure. You have to consider only 2 significant figure. When you are multiplying or when you are dividing, you have to take the least one. When you are dividing also, you have to consider the number which is having the least significant figure, while in the final answer, while multiplying also you have to consider the least significant figure. So in this case, how much it will be? 7.7 after correcting it to correct significant figure. So 7.7 is your answer. 7.7 is your answer. Fine. Next, for a traveling harmonic wave, 2.0 cos 2 pi 10t 0.0080x plus 0.35, where x and y are in centimeter and t in second, the phase difference between oscillatory motion of 2 points separated by a distance of 0.5 meter is. What is the phase difference between oscillatory motion of 2 points separated by a distance of 0.5 meter? See this question. So y is equal to 2 cos 2 pi. I am multiplying. Let's multiply it. So 2 pi into 10, it will be 20 pi t minus, multiply it. So 2 pi into 0.0080x plus 2 pi into 0.35. This much we are getting, correct? Okay, fine. No worry, we could have done it directly also. What they are asking, the phase difference between oscillatory motion of 2 points separated by a distance of 0.5 meter. So you have to find out the phase difference between the 2 points separated by a distance of 0.5 meter. What we should do here? What we should do here? See, Phase difference relation you already know. Already we have done it. 2 pi by lambda into delta x. Somehow if you are able to find out, delta x is already given. Somehow if you are able to find out this lambda, your work is done. And lambda from where you will get? This is your k. Remember, k is equal to 2 pi by lambda. So lambda is equal to 2 pi by k. So put that value. 2 pi divided by k is 2 pi into 0.0080. 2 pi cancel. So put that value. So k is equal to 2 pi by lambda is 0.008008. That's what now? Into delta x 0.5. 0.5 is 2. What they are asking? Pi. Delta phi. Oh, y is in centimeter, where x and y is in centimeter. Okay, x is in centimeter. So this one is in centimeter. So we have to multiply it by 10 to the power minus 2. So 10 to the power 2 will come here. It is in centimeter, it is in given. So to convert it to meter, we have to multiply it by 10 to the power minus 2. So you have to, see the unit as well, right? So how much it will become? Y r in centimeter, t in second, the phase difference 0.5 meter. So 2 pi, so delta phi. So how much you will get? Delta phi is equal to 2 pi, 2 into 0.5 is 1, 1 divided by 8 into 10 power 3 into 10 power 2. Now you can just divide it 100. So 4, 4, 2, 425, correct? 50, 10. So 5 into 25 into 10 to the power, where is pi is missing? Pi is also there. Did I made any mistake? 0.08 thousand lambda. Oh. Sorry. One mistake I have made by putting the values. That's why we are getting very big value. One mistake I have made. Just correct this one. So 2 pi lambda value is 1 divided by 8 into 10 to the power how much? 1, 2, 3. So 10 to the power minus 5. So it is 10 to the power 5 divided by 8. Correct? So lambda is equal to. So here lambda is equal to 10 to the power 5 into 8 will come. Correct? Fine. Any confusion? And here 0.5. And delta x is 0.5. So 0.5 into 2 is 1. So it is 8 pi into 10 to the power minus 5 radian. To 1. 0.008, 1, 2, 3. So 10 to the power minus 2. 0.008. So 10 to the power minus 5, that's correct. So 10 to the power 5 will go. So 10 to the power 5, fine. 8, 0.5 into 2, that is 1. So 8 pi into 10 to the power minus 5 radian. So we are not getting any options here. X is in centimeter. 10 to the power 2. Did I made a, let's do it. Okay, so maybe some calculation mistake I have done, but the process is same. I'm keeping it in centimeter itself. So 2 pi divided by 2 pi into, let it be 0.008. Oh, this is this is not your centimeter, this is just a number. That's what I also converted. This is just a number. So it's 0.008 into delta x is 0.5. If you want, just multiply, let's convert it into centimeter because every value is given in. So I'm multiplying by 100. Let's do it. So how much we will get? So 50 into 2 pi, this 2 pi and 2 pi will cancel it, cancel it. 2 pi by lambda, what I am doing, 2 pi into 0.008 into 50, 0.5 meter is 50 centimeter. Now you will get that answer. 2 pi, so 2 pi is not here. So 2 pi into 0.008 into 50. So how much you are going to get? 50 into 200. So 100 it will multiply here. So 2 point will shift. So 0.8 pi radian you are going to get. See, so you should be very careful about the calculation mistake. What mistake I was doing? So I was substituting lambda value as 1 by lambda, right? So you should be very careful. This one is 1 by lambda. So lambda value when you are calculating, you should substitute it like this. Clear? Fine. So that's mistake I was doing. So now you will get 0.58 pi radian. So which one is the correct option? Option number 4 is the correct option. Next. Let's see, a ray of monochromatic light is passing through an equilateral prism ABC as shown in the figure. The refracted ray QR is parallel to its base and the angle of incidence is 50 degree. Angle of incidence is 50 degree. Okay, this angle is also given, it is 50 degree. Fine. Then the angle of deviation is, what is the value of delta? This delta. What is the value of this delta? So what is the relation in this case? Since when it is parallel, when it will become parallel, then this angle and this angle will become equal. And you know that relation, A is equal to R1 plus R2. A is equal to R1 plus R2. And so what is the value of this R? So this R value is A by 2. A by 2, because R1 equal to R2, that is equal to R. So this is your R, this is your R. So R1 is equal to R2 and that angle will become 30 degree. Any confusion? No. Now what is the value of R then? 30 degree. What we have to calculate? Angle of deviation. Then this is 30 degree. What about this angle? What about this angle? This is 30, so this angle will be 60 degree. Because this one is normal, no? Normal, sorry, this normal to the surface. Oh, my mistake. Direct formula also you can use, or you can do it like this. This one is 30 degree. What about this angle? This is this angle is 50 degree. Just see which angle I am talking about. This one and this one. This angle is 50 degree. This is 30, so this angle will be 20 degree. Correct? So this angle is 20, so this angle is also 20 degree. So delta is equal to 20 plus 20, that is 40 degree. So what is your angle of deviation? Angle of deviation will come out to be 40 degree. Option number 1 is correct. Or one more formula is there, direct also formula you can use. Delta is equal to I plus E minus A. So what is your I? 50. What is your E? 50 minus A is 60. 100 minus 60 is 40 degree. So I am giving you both the ways. If you don't remember the formula, how you should proceed. If you remember the formula, how you should proceed. Next. In the circuit shown below, the voltage appearing across the diode D will be of the form, right? See this one? In the circuit shown below, the voltage appearing across the diode D will be of the form. Which form it will be? You are giving this input. This one is positive cycle, this one is negative cycle. So this one is negative, this one is negative, this one is positive, right? PN junction diode. So when you are feeding a negative cycle, means you are feeding a negative cycle here. Correct or not? When you are feeding a negative cycle, you are feeding a negative cycle here. So negative cycle means the current will flow like this. Will it flow? Yes, you will get an input. You will get an input, right? If you are feeding a positive cycle, will you get an input? No input. Option number 2. Only one option is satisfying, which is your option number 2, right? Okay, let's see the next question. For a simple pendulum having time period t, the variation of kinetic energy with time t is, okay, kinetic energy, is it negative? So kinetic energy, it is always positive. Yes or no? First thing. So kinetic energy will always be a positive one, and for a simple pendulum having time period t, the variation of kinetic energy with time t is, how the variation of kinetic energy with time t. Now, definitely, when your kinetic energy is maximum, when the kinetic energy is maximum, when your kinetic energy is maximum, when the particle is at its mean position, right? So when a particle is at mean position, when your particle is at mean position at t is equal to 0, comma t by 2, these are the time periods when the particle is at mean position. Correct or not? So it is going t by 4. See, it is going t by 4. Then it is coming back. So again 0, t by 2, then t by 4, then coming back. So ultimately what is happening? At 0, t by 2 and t, the particle is at mean position. So kinetic energy should be, wait. At t is equal to 0. Yes. So here, no, not this one. Okay. The particle, when we are talking about the pendulum, no? So at initially the pendulum is released from here. I was taking from here. So when you are releasing a pendulum from this point, at that point we are considering it to be 0, right? Correct or not? So when it will have a maximum kinetic energy when it is t by 4. Then again it will go this side. Again t by 2. Again its kinetic energy will be 0. Kinetic energy will be equal to 0, and t is equal to 0. Again its kinetic energy will be 0, right? Initially. Yes or no? So at t by 2 or at t, it is at extreme position, and at extreme position you know that its velocity is 0, that's why kinetic energy is 0. One thing is very simple. It's, can you tell me, if it is a pendulum, how you should approach? If it is a pendulum, first one, kinetic energy is always positive, so this option and this option is neglected. Second option, is kinetic energy constant? Is it constant? Is it speed is constant throughout the journey? No, it is changing, so this is also wrong. So correct option is option number 3. Next, a resistor is connected to a battery of 12 volt. A resistor is connected to a battery of 12 volt. A resistor is connected a battery of 12 volt. This is your R. And battery is having internal resistance 2 ohm. This battery itself is having internal resistance 2 ohm. The current in the circuit 0. I don't think this is a very typical question. This is 0.6 ampere. You won't find easier than this question. You can simply use the Kirchhoff law. You have to find out if the current in the circuit is 0.6 ampere, the terminal voltage of the battery is. If the current in the circuit is 0.6 ampere, what is the terminal voltage across the, what is the terminal voltage? Means you have to find out the voltage across this R. R is We don't know. Okay, we will calculate, no problem. So can we use the Kirchhoff law? Yes. 12 minus 0.6 into r plus 2, that is coming out to be 0. That will come out to be 0, right? Yes or no? So what you are going to get, 12 is equal to 0.6 r plus 0.6 into 2. You can solve it according to your wish, how you are doing. It's better, instead of doing this, we can write 12 divided by 0.6 is equal to r plus 2. So it is 120 divided by 6 is equal to r plus 2. You know, that's 620. So what is the value of r? 18 ohm. What is the value of r? 18 ohm. You got the value of r as 18 ohm. Now what is the current, what is the voltage drop? So terminal voltage is equal to I into r. So I is 0.6, r is 18. Correct? So 18 into 0.6, you can simply 6 by 10 into 18. It's easy, you can do it, right? How much you are getting? 108 divided by 10, so it is 10.8 ampere. Yes or no? Volt. 10.8 volt. So what is the voltage across it? 10.8 volt. Next one, the amount of work done to raise a mass m from the surface of the earth to a height equal to the radius of earth r. So if you remember the formula, this is your height h, this is your radius r. So there is one simple formula, change in potential energy, what there are amount of work done. So work done is what? Change in the potential energy. So and change in the potential energy will be given by mgh divided by 1 plus h by r. Change in the potential energy is given by mgh divided by 1 plus h by r, right? So you have to find out the work done to raise it m into g to a height equal to the radius of the earth divided by 1 plus r by r. So this is 1 by 2 mg r. Done. Right? How much work is being done? mgr by 2. Can I change? Fine. An electric heater supplies heat to a system at a rate of 100 watt. If the system performs work at a rate of 75 joule per second, then the rate at which internal energy increases will be the rate at which its internal energy is going to increase. Fine. So what do you think? What should we do? An electric heater supplies heat to a system at a rate of 100 watt. So power is given as 100 watt. Means what is this? You know that Q is equal to U plus W. They are talking about the internal energy. So Q means dQ by dt, du by dt plus dW by dt. Right? An electric heater supplies heat to the system. So dQ by dt, it is given as 100. So 100 is equal to du by dt. We need to find out. Du by dt we need to find out. Work, it performs work at the 75 joule per second. So 75 watt. 100 minus 75, it is 25. That is equal to du by dt. So very simple question it is. It's a very simple question. So which one is the correct? 25 watt. Right? Correct. Next one. A room heater is rated 400 watt 220 volt. If the supply voltage drops to 200 volt, what will be the power consumed? A room heater is rated with the help of rated voltage, whatever is rated power. What we should do? With the help of rated power, you should always what is going to be constant? Do you think it is always 220 volt? Voltage is always constant? No. Current is always constant? No. What is constant? If this is rated, your resistance will be constant. So with the help of rated power, rated value, we will calculate the resistance. So power is equal to V square by R. Right? So 400, V square is 220 into 220 divided by R. So R will be equal to 220 into 220 divided by 400. 0 0 0 0 2 2 11 2 11. So it is 121 ohm. We got the 121 ohm. So what will be the power consumed approximately? 200 volts. So power is equal to again V square by R. So what is your V square? 200. So 200 into 200 divided by 121. That's why they have given approximately. So what is its approximate value? 400 divided by 100 means it will come out to be 400 into 100, right, divided by 121. So definitely this value is less than 4, means this overall value, this overall value will be less than 4 and more than 2. How you should proceed? This value you should not divide. You don't have a time to divide. This value is less than 4 and more than 2. Which one is less than 4 and more than 2? 331 watt. Right? Next. When a ruler falls vertically, 5 different persons catch it with different reaction time. Person A has reaction time of 0.2 second. Person B has reaction time of 0.22 second. Person C has reaction time of 0.18 second. Person D has reaction time of 0.19 second. Person E has reaction time of 0.21 second. What is the correct order of the distance traveled by the ruler for each person? Definitely more reaction time, more distance it will travel. Simple. More reaction time, more distance it will travel. So which one? B will be the maximum. After that, which one is having less than that? B, then E, and then B, E, then A. B, E, A. So these options is gone. Then which one? B, E, A, then D, and then C. B, E, A, D. Option number 4. That's it. More reaction time means it is taking, it will travel more. Next. Consider two uncharged capacitors of equal capacitance 200 picofarad. One of them is charged by a 100 volt supply and disconnected. Now this capacitor is connected to the uncharged capacitor. The amount of electrostatic energy lost in the process is, okay, two uncharged capacitor of equal capacitance. See how easy paper they have, made. Straight means, this is the paper. If you have done your PYQs also, you will get the similar type of questions. Two uncharged capacitor of equal capacitance 200 picofarad. One of them is charged by a 100 volt supply. You are charging and disconnected. Now this capacitor is connected to the uncharged capacitor. So it is a question of a common potential. Now you are connecting it to the uncharged capacitor. It is being charged to 200 pico 100 volt supply. So what is the common potential? V common. C1 V1 plus C2 V2 divided by C1 plus C2. If you remember it, how much it will become? 200 into 100. Pico is 10 to the power minus 12. V2 is 0 divided by C1 plus C2. So C1 plus C2 is 400 into 10 to the power minus 12. Cancel. 200 to 250. So how much you are getting? 50 volt. Right? How much you are getting? Common potential is 50 volt. So common potential is 50 volt. What they are asking? Amount of energy lost. What is the amount of energy lost? It's energy lost. You can use the simple formula also. If you remember, what is that formula? So I'm using this one. Initial energy minus final energy. So how much it is? Half. Initial energy is C V square minus half C equivalent into V square. The V common square. Right? Correct? Half into 100, 200. V square. V square is 100 square minus half into C equivalent is C1 plus C2, that is 400 into 50 square. You can take so many expressions. You can take half into 200. I can take common. Then 50 square I can take common. So inside it will be 1 minus 50. So here we can write 100 into 100. So 50 into 50. So it is 4. Yes or no? So 4 minus, here it is 2. So it is 2. If you remember the formula, you can do it directly also. So 100, if you don't remember it, I am giving you the way how to proceed. So 100 into 2 into 50 square into picofarad, 10 to the power minus 12. Minus 12 will also be there. So whatever the answer you are getting, how much answer we will get? 100 into 2, 100 into 2, 100 into 2 into 50 square into, so it is coming out to be energy lost that is will come out to be 50 square, that is 25 into 2 into 10 square, that is 100, 10 to the power 4 into 10 power minus 12. Correct? So 50 or 5 into 10 power 5 into 10 power minus 12. So it is coming out to be 5 into 10 to the power minus 7 joule. So this one is 0.5 into 10 power minus 6 joule. So 0.5 into 10 power minus 6 joule, that is your correct answer. It's okay. Next, Savita, a class 11th standard student, while conducting an experiment to determine the effective length of a simple pendulum L, notes down the data of time taken to complete 30 oscillation as 60 seconds, and hence calculates the length of the simple pendulum as. So you have to calculate the length of the simple pendulum. Can you please tell me the formula for the length of the simple pendulum? T is equal to 2 pi root over L by G. Right? So for that length, to calculate the length, what is being required? We need time period, we need G is fine, already given. So we need time period. So what is your time period? 30 oscillation in 60 seconds. So 60 divided by 30. What is your time period? 2 seconds. Square it. So T square is equal to 4 pi square L by G. So L will be equal to T square into G divided by 4 pi square. Pi square value is approximately equal to 9.8 or 10 also we are taking sometimes. So L equal to T square, that is 2 square, 4 into 9.8 divided by 4 pi square value is, it is given, we can take it as 9.8. This one will be cancelled, so L is equal to 1 meter. So easy question. So how much you are getting the length as? Length is equal to 1 meter. Fine. Next, the peak value of an alternating current is 5 ampere. The peak value of this alternating current is 5 ampere. Now you have to find out frequency is given as 60 Hz. How long will the current starting from 0 take to reach the peak value? How much the current will take to reach to the peak value? Okay. Peak value means what is given? I naught is given. How much it is? 5 ampere. Frequency 60 Hz. How long will the current starting from 0 take to reach the peak value? How much time it will take to reach to the peak value? You know that equation, I is equal to I naught sine omega t. Yes or no? I should be equal to, the peak value is given as 50 ampere. So I don't think we need this. So I should be equal to I naught. So I naught is equal to I naught sine omega t. Right? So this one will be cancelled out. So sine omega t, that must be equal to 1. So omega t must be equal to pi by 2. So omega is 2 pi f. Omega is 2 pi f. F is 60 into time t, that is equal to pi by 2. Pi cancel. So t is equal to 1 by 60 into 2, 120 into 2, that is 240 second. How much time it will take to reach to the peak value? 1 by 240 second. Which one is correct option? Option number 1. It's fine. Next, in interference and diffraction, the light energy is redistributed. If it reduces in one region, producing a dark fringe, it increases in another region, producing a bright fringe. As there is no gain or loss of energy, these phenomena are consistent with the principle of conservation of energy. Diffraction and interference are characteristics exhibited only by light waves. Choose the correct answer from the option given below. A is true, but B is false. A is true, B is false. Definitely diffraction and interference, these are the phenomena of all the waves. This is not the phenomena of only light wave. Correct? So this is the phenomena of all the waves, not only by the light waves. So A is true, but B is false. Right? A is true. As there is no gain or loss of energy, these phenomena are consistent with the principle of conservation of energy. This one is correct. But B is not correct, because this diffraction and interference are characteristic of all the waves. A box of mass 1.5 kg is kept on the floor of a stationary trolley. The coefficient of static friction between the box and the trolley is 0.12. Keeping the box in stationary state over the trolley, the maximum acceleration with which the trolley can move horizontally. A box of mass 15 kg is kept on a trolley. The coefficient of static friction between the box, so mu is equal to 0.12. Keeping the box in a stationary state over the trolley, the maximum acceleration with which the trolley can be moved horizontally. So what is the maximum acceleration with which the trolley can move horizontally? In meter per second square. Okay, fine. In this case, what we need to do, when it is accelerating, it will experience a pseudo force, right? F is equal to mass of the object into acceleration of the frame. Pseudo force is equal to mass of the object where the pseudo force is acting into acceleration of the frame in the opposite direction. So, and this ma, to make it stationary, this ma must be equal to limiting friction. So what is the maximum acceleration? A max is equal to mu into g. A max is equal to mu into g. So how much it will become? 1.2. 0.12 into g, 10. So 1.2. Option 4. Next, the sum of kinetic energy and potential energy of a simple pendulum bob is 0.02 joule. Okay, total energy basically 0.02 joule total energy. The speed of the simple pendulum bob at equilibrium position is approximately the speed of the simple pendulum bob at equilibrium position. Equilibrium position means where the force is 0. Equilibrium position means where the force is 0, right? And at that point, you know that its potential energy will be 0. If I say, if you are considering that reference point to be 0, so potential energy will be 0 at that point, right? So kinetic energy will be equal to 0.02 joule. All of its energy will be in the form of kinetic energy. Fine. So what we have to calculate? The speed. So speed 0.2 joule is equal to half mv square. Mass of the bob is 20 gram. Half into 20 into 10 power minus 3 into v square, and here it is 2 into 10 power minus 2. Correct? 10. So here 10 into 10 power minus 3. So this 10 power minus 2, 10 power minus 2 cancel. So v square is equal to 2. So v is equal to root 2. Root 2 1.41 meter per second. That's it. So easy question it is. It can be done within fraction of seconds. Next, 4 statements are given. A is mass number. The volume of a nucleus is proportional to, yes. volume of a nucleus is not proportional to it. Volume of nucleus is proportional to A. Volume of a nucleus is proportional to A, right? Right? Correct? The volume of a nucleus is proportional to A to the power 1 by 3 it is given. The volume of a nucleus is proportional to A. So it is B is correct. The difference in mass of an atom and its nucleus is called the mass defect. The difference in mass of an atom and the nucleus is called its mass defect. The difference in mass of a nucleus and its constituents is called its mass defect. So B and D is correct. So B and D are true, but A and C are false. So B and D are true, right? So C is false, D is true, A is false. So option number 1 is correct. Option number 1 is correct. Next. The angular speed of a flywheel is increased from 600 rpm to 1200 rpm. So omega naught is equal to 600 rpm. Rpm means rotation per minute. So it is 2 pi by 60. Correct? So 60, 10, 20 pi. This is 20 pi radian per second. What is your omega final? Omega final is 1200 rpm. So 1200 into 2 pi divided by 60. 20. 40 pi radian per second. Now what they are asking? The number of revolution completed by the flywheel during this time is how many number of revolution it will complete. So omega final is given. So theta is equal to omega naught into t plus half alpha. Which equation we should use? Anyway, we have to calculate the alpha. So alpha is equal to omega final minus omega initial divided by time t. So omega final 40 pi minus 20 pi divided by time t is 10 second. So it is 20 pi by 10, that is equal to 2 pi, right? Second, radian per second square. Radian per second square. Alpha we got. So anyway, you can calculate which equation if you want. Anyone, if you want, you can use this equation also. Omega final square minus omega initial square, that is equal to 2 alpha theta, right? Correct? Or else we can use the formula theta is equal to, we can use this formula also, omega naught into t plus half alpha t square. That also omega naught, even if you are not it is already done, so we have calculated. So whatever you want, you can use it. So let's write it. Omega naught is how much? 20 pi. So 20 into 10 pi plus half. Alpha is how much? 2 pi. 2 pi into t square, 100. So you are free to use any equation. 200 pi plus 100 pi, that is 300 pi. 300 pi. So how many revolution? 150 revolution. Means we can write it now, 150 into 2 pi. 150 into 2 pi. So how many revolution? 150 revolution. Done. Next. A submarine is designed to withstand an absolute pressure of 100 atm. Now submarine is designed in such a way that it can withstand an absolute pressure of 100 atm. How deep can it go below the water surface? So 100 atm pressure you have to check. So at what depth it will become 100 atm, right? Suppose this is a submarine. Submarine is there, fine. Submarine is there and it is going to the depth. Let's assume this depth is h. So at this point, what is the pressure? P naught plus rho gh, right? That is equal to 100 P naught. So rho gh, that must be equal to 99 P naught. What we have to calculate? How deep can it go? So h will be equal to 99 P naught divided by rho into G. Just put that value. So H will be equal to 99 into P naught. P naught is 10 to the power 5 divided by density is 1000, 10 to the power 3 into G value is 10. 10. So 990 meter. How much it can go? 990 meter. That's it. How much depth it can go? 990 meter. Very easy. Let's move to next. Match list 1. So if you remember this data, you can easily get to the solution, right? So this data microwave, I'll just go through it. So it is microwave is from klystron valve or magnetron valve. Visible light, vibration of atoms and molecule. Electron in atom emit light when they move from a higher energy level to a lower energy level. See gamma rays. So visible light, it is electron jumping from where it is. Electrons in atoms emit light when they are moving. See, it's a you could have gone through this already. It is mentioned here. Electrons in atoms emit light. Emit light means what? Visible light I am talking about. So B option is 1. B is 1. So either this one is wrong, this one is wrong. So either this one is correct, 1 is correct, or option number 4 is correct. Correct. Now we have to see. So B is 1. Now let's talk about the infrared radiation. What is infrared radiation? Infrared rays. So infrared rays, vibration of atoms and molecules. So this, choose which one you know. Forget about microwave, but I know infrared, right? I know this visible light. It is already mentioned here. Emit light. So D is option 3. Which one is D is option 3? Check it. D is option 3. So this one is the correct option. Option number 4 is the correct one. Option number 4 is the correct one. Done. Can you move to next? Next one. Which of the following statements are correct? Inside a conductor, the electrostatic field is 0. Inside a conductor, that is correct. Electric field at the surface of a charged conductor does not depend on its surface charge density. Electric field at the surface of a charged conductor does not depend on its surface charge density. The interior of a charged conductor can have no excess charge in the static situation. At the surface of a charged conductor, the electrostatic field must be normal to the surface at every point, right? Then E, the electrostatic potential is 0 everywhere inside a charged conductor. So electric field is 0. So electrostatic potential is constant. So E is straightforward wrong. E is your straightforward wrong. So E is wrong, E is wrong. So which option is wrong? This one is wrong, this one is wrong. So A, B, D. So A is correct. Electric field at the surface of a charged conductor. So surface of a charged conductor does not depend on its surface charge density. It depends on its surface charge density. More surface charge density means more electric field. We know this thing. So B is correct. Now let's talk about C. The interior of a charged conductor can have no excess charge. So no excess charge. B is, I think, false. It depends, right? So B is false. It does not, conductor does not. Oh, it is given does not depend, but it depends. That's what I told. It depends. So B is your false. Let's talk about B is false. So you know that which one is the correct option. A, C and D only. But let's check it. The interior of a charged conductor can have no excess charge in the static situation. That is correct. If you are talking about the charged conductor, you know all of its charge comes out to the reside in its outermost surface. At the surface of a charged conductor, the electrostatic field must be normal to the surface. Yes, it must be normal to the surface. Otherwise, if it makes some angle, then it will give rise to a surface current, which is not possible. So A, C and D is correct. For a metal of work function 6.3, phi is given as 6.6 electron volt. Which of the following wavelength of incident radiation does not give rise to the photoelectric effect? So which wavelength will not give rise to a photoelectric effect? You know that wavelength should be less than a threshold wavelength. Wavelength should be less than threshold wavelength, and frequency should be more than only photoelectric emission should be more. First thing, less than they are saying does not give rise to the photoelectric. Just use some common sense. Wavelength is more. If wavelength is more, frequency is less. Wavelength is more, frequency is less. And the question is, does not give rise to the photoelectric effect. So choose the which is having the highest wavelength. Do you think you have to solve this question? No. Suppose you are getting 100 nanometer. If it is not, if for 100 nanometer, if this one photoelectric effect is not happening, do you think for 200 nanometer photoelectric effect will happen? For 200 nanometer, the frequency will be less. Wavelength is more, frequency will more less. So for this one also it is not going to happen. Then it will become multiple choice. Am I clear? So choose the option which is having highest wavelength. So which one is having highest wavelength? 200 nanometer. Or else you should write hc by lambda and see which wavelength it is satisfying. From there you will get. Is it fine? Is it okay? Next. In the first excited state of hydrogen atom, the energy of its electron is minus 3.4 electron volt. Okay, total energy is given. Total energy is minus 3.4 electron volt. The radial distance of the electron from the hydrogen nucleus in this case is approximately. What is the radial distance of the electron from the hydrogen nucleus in this case? Radial distance you have to find out. So what to do? So for that we will use the equation. Which one? In the first excited state of hydrogen atom, the energy of its electron is minus 3.4 electron volt. The radial distance of the electron from the hydrogen nucleus in the case is approximately. So suppose this is your hydrogen atom. So you are talking about first excited state, means what? N equal to 2. What is the meaning of first excited state? N equal to 2, right? Correct. Now energy. What is the energy expression? Minus 1 by 4 pi epsilon naught kq by r square. So what is the q here? E square by r square. Oh, sorry, kq by r. Kq1 q2 by r. This is the energy. So this is given as minus 3.4 electron volt. Correct. One more formula is there that I'll give you. Radius of hydrogen atom. How much we will get? From there r we have to calculate. So E square divided by 4 pi epsilon naught into r. So r value you can calculate, you can put it 1 E and E will cancel it out. Correct. So r equal to E divided by 1 by 4 pi epsilon naught. Can I write it directly? 9 into 10 power 9 divided by 3.4. Correct. So here 1 E is cancelled. Then E is 1.6 into 10 power minus 19 into 9 into 10 power 19. 9 into 10 power 9 divided by 3.4. So let's solve it and let's check how much answer we are getting. Oh, we are talking about the total energy, right? So one thing I missed. This one is total energy. So here 2R will come. 1 by 2, it is 1 by 2, right? Total energy. So 1 by 2 will come. 1 by 2 I missed. So 1 by 2 will come. So here 2 into 3.4 will be there. 2 into 3. Let me check the Okay, let me calculate this one. So 1.6 into 9 divided by 6.8. 2.11 2.11 into 10 to the power minus 10 minus 10. So which one? 2.1 into 10 power minus 10. This one. So option number 4 is the correct one. Let's move to question number 44. The statement are given below. When the forward bias voltage across a PN junction diode increases above a certain threshold voltage, the diode current increases significantly. This current is called reverse saturation current. Forward bias you are increasing, forward bias current you are increasing. So how it will be called as reverse saturation? Just think how it will be called as reverse saturation. So this statement is false statement. Only this statement is correct. That is correct, but second statement is false. Statement A is true, but statement B is false. A flask contain argon and chlorine in the ratio of 2:1 by mass. The temperature of the mixture is at 27 degrees centigrade. The ratio of root mean square speed of the molecules of the two gases. So what is the ratio of root mean square speed of the molecules of the two gases? Okay, tell me the formula of root mean square, VRMS. What is the formula? VRMS formula root over 3RT by M. So VRMS formula is root over 3RT by M. So what they are asking, temperature is fixed. Flask contain argon and chlorine in the ratio 2:1 by mass. It is given by molar mass, right? 3RT by M, that's correct. Temperature is fine. Root mean square we have to calculate 17U. Atomic mass of argon 40U and molecular mass of chlorine is 70U. So we have to okay, fine. So we'll put the value. So here, so VRMS is what we are getting is inversely proportional to 1 by root M. So argon, first it is argon, V argon divided by V chlorine root over mass of chlorine divided by mass of argon, molar mass. So what is the molar mass? Oh, same molar mass, number of you can divide it, 70 divided by 40, 70 divided by 40, 0 cancel, so it is root over 7 by 2. So correct answer is root over 7 by 2, option number 1. Fine. So that's all. So this is all about your physics paper. So you tell me, how is it difficult? Even if you leave 1 or 2 questions, because that is not difficult. Yes, some calculation part was there, but it is doable. So make work on a proper strategy. If you are giving an examination, give the examination in such a way so that you should at least read all the questions. Try to do experiments. If you are appearing for 2027 NEET, give experiment. Like first, in some cases, start with the botany. Some cases start with the zoology. Some cases start with chemistry. Some cases give a chance to the physics as well. And let's check which strategy is suitable for you, right? And this paper was relatively, it is moderate, I'll say. So that's all for today. Thank you. We'll meet again. Thank you.